Hello, this is the guide to calculations for experiment 9, the molar volume of carbon dioxide. Hopefully for each of the sections your notebook looks a little bit more organized than this. I had kind of threw some things together from other data, but with these values, the minimum of these values, you should be able to do your calculations for the lab experiment. So the first one that you're asked to do is in part C. And I had recorded this earlier, but the video didn't work, so I'm just redoing this part. So the first part, you're calculating pressure of dry CO2, and that's equivalent to the barometric pressure, which was on the board in the lab, minus the vapor pressure of water. The vapor pressure of water can be found in the Appendix F on page 111. And that is based off of the temperature of your water. So the temperature of my water bath was 21 degrees. So the vapor pressure at 21 degrees is 18.7. So the barometric pressure on the board was in millimeters of mercury. And so that's the same thing as torr. And then the 18.7 was the value from the appendix. So doing a subtraction, you get 724.3 torr for the pressure of dry CO2. The next calculation is in part D, and that's determining the mass of the CO2 generator and its contents. So you can see how much CO2 is evolved. So this is of CO2. Okay, so the mass of CO2 evolved is equal to the mass of the generator before, which for me is 57.340 grams, minus the mass of the generator after, which is 57.306. So my mass of CO2 is 0.034 grams of CO2. All right, so that is part D, and you'll have to do that for each trial, but I won't do that all in this video here. For part E is the next calculation. Okay, so for part E you have the molar volume of CO2 gas, and that should be in liters. So we take the VCO2 experimental, so that is the volume that you collected of gas, which should be, well for me, was 17.2 mils that were displaced, and then that's minus 0. So again, if you filled your graduated cylinder and there was no air bubbles, your initial volume should be 0 mils. So this will be, I'll just put 17, oops, this is 0.017 liters minus 0.00 liters. Times PCO2, which is the dry CO2 that you found in part C. And that's over 760 torr. And then 273 K over the 21 plus 273. And 21 is the temperature of the water. So you do the calculation there, and that ends up being 0.0150 liters. This should be 2 here. All right, so we have 3 significant figures. Okay, so for part E continued, this is the second question. So determine the molar volume of CO2 in liters per mole. The formula is molar volume of CO2 equals VCO2 at STP over the number of carbon dioxide. So the VCO2 you determined in the last step down here, so that was the 0.015. In order to get the number of moles of CO2, we need to find the moles of CO2, and that's going to be based off the grams of CO2 that you found in part D. So I'm just going to aside here, this would be okay, so to get from moles of CO2, I need to use the molecular weight, which is 1 carbon plus 2 oxygen, so that is 44.01 grams per mole. So it'd be, and that's CO2. So for 1 mole of CO2, it is 44.01 grams of CO2. So these units will cancel, and I get 0.000773 moles, or 7.73 times 10 to the negative 4. Okay, so again, the molar volume equals 0.0150 liters, and that was from part E, step 1, divided by 7.73 times 10 to the negative 4th moles. Should be 19.4 liters per mole. Alright, so that's for part E. The next calculations will be part F. And again, you'll have to do these for each of the 3 trials that you did. I'm just doing it for one so you can see the example here. Okay, so for the first part in F, just put a number here. Determine the moles of CaCO3 in the sample from moles of CO2 generated. So for trial 1, the ratio is 1 to 1. So if I made 1 mole of CO2, that had to use up 1 mole of CaCO3. So that means for trial 1, there are 7.73 times 10 to the negative 4th moles of CaCO3. All right, number 2, mass of CaCO3. In the first I'm going to do for trial 1. So that first portion. So if you have 7.73 times 10 to the negative 4th moles, we need to get the molecular mass of this, because we need to go through that to get to grams of CaCO3. Alright, so the mass is 100.9 grams. So the total here is 0.0774 grams of CaCO3. Okay, so that's for trial 1, so that's how you would do that. And you can do that again for each of the samples and then total up the number for the whole tablet for all 3 of these. For number 3, determine the percent calcium carbonate in each of the portions. That would just be the 0.0774 grams of CaCO3. This is for trial 1. Divided by the total mass. So that's the total portion mass times 100. Okay, so if I go back to my first page of numbers here, the first portion was 0.377 grams. So this would be 0.377 grams of Tums times 100. And this comes out to be 20.5%. And again, you'll do that for each of the tablets and get your percentages there. And then for the total tablet. So if my values were 0.0731 grams, Okay, so my percentages here, we had 19.1% for trial 2. This is trial 2. Trial 3 was 19.3%. So the mass of my calcium carbonate total equals the sum of all of the .203 grams. Alright, so that would be the total mass of calcium carbonate in the Tums tablet. Alright, so then to determine the percentage in the total tablet, just going to carry that number over here, so 0.203 divided by the total mass, which was 1.157. .5%. So to figure out your percent error, so this is 4 of part F, that's just the percent error is experimental minus theoretical over the theoretical. So my experimental was, the total was 0.203 grams, minus the theoretical was 0.500 grams over so that's 59.4% error. Alright, so that's how you do the calculations for experiment 9.